Hello friends, welcome back to another Python tutorial. Have you ever wondered how Python finds where your data lives inside a dictionary or a set so fast? The secret behind all that speed is a simple but powerful function called hash. In this video, we'll explore what hashing means, how hash works in Python, and where it's used in real programs. Part 1. What is a hash? In simple words, the hash function returns a unique integer that represents an object. That number helps Python store and retrieve data lightning fast. Example: I define a variable and assign it 42. Let's print it. Let's print hash x and run it and print 42. I define a variable and assign it Python and print hash text and print it and print hash. Each time you call hash on a value, Python gives you a numeric fingerprint of it. So here both 42 and Python have their own unique hash values. Part 2. Why hashing matters. Hashing is the foundation of data structures like sets and dictionaries in Python. Whenever you use a dictionary key, Python actually calculates its hash to decide where to store its value. Example: why hashing matters. I define a variable and assign it a dictionary. Print hash apple. Print data apple. Let's print it and print 10 and hash. Okay, part 3. Hashable objects. Not every object in Python is hashable. Only immutable objects, ones that don't change, can have a stable hash. That's why numbers, strings, and tuples are hashable, while lists and dictionaries aren't. Example: print hash 100. Let's print it and print 100. Let's print hash hello, hashable. Let's print hash 123 in tuple. Lists are not hashable. I define a variable and assign it a list. Let's print it. Output type error, unhashable type list. Okay, unhashable type list. Okay. Lists and dictionaries can change, so Python can't rely on their hash being the same letter. Part 4. Real use case. Duplicate detection in sets. Sets use hashing under the hood to automatically remove duplicates. Example: I define real use case duplicate detection in sets. I define a variable and assign it a dictionary. Let's print and print in for loop. Okay, let's print it and print 10, 20 and 30. Okay, using those hash values, Python quickly recognizes that 10 already exists and avoids adding it again. Part 5. Custom hashing for your own classes. You can even define your own hash function for custom objects by implementing underscore underscore hash underscore underscore and underscore underscore eq underscore underscore. You tell Python how your object should behave in hash based collections. Example: custom hashing for your own classes. Excuse me. Self ID. Okay. Two students with the same ID. I define a variable and assign it a student Ali and 101. I define a variable and assign it a student Reza 101. Print len students. Let's run it and print 1. Okay, because both students share the same student ID underscore ID, our custom hash function treats them as equal, so only one of them is stored in the set. Part 6. Recap and takeaway. Let's review what we've learned today. Hash generates a unique number that represents an object. Immutable objects are hashable, like strings, numbers, tuples. Hashing powers Python dictionaries and sets. You can customize hashing in your own classes. If you enjoyed this lesson, hit that like button, subscribe for more Python magic, and comment below what topic you'd love to see next. Until next time, keep coding, keep learning, and enjoy Python.